Here are some problems about local minima and maxima. Problem 1. Find all critical points of f of x equals x squared minus 5x and classify them as local minima, maxima, or neither. First, let's take the derivative of f. F prime of x is equal to 2x minus 5. Now, critical points occur whenever the derivative is either 0 or doesn't exist. This is a linear function which exists everywhere, so we only need to check where it's 0. If 0 equals 2x minus 5, then 2x is equal to 5, so x is equal to 5 halves. Therefore, the only critical point is x equals 5 halves. And 5 halves is a local minimum. This is because f of x is equal to x squared minus 5x, which is a parabola that curves upwards as the coefficient of x squared is positive. Problem 2. Find all critical points of f of x equals x cubed minus 3x squared plus 6x and classify them as local minima, maxima, or neither. The first step is to take the derivative of f. F prime of x is equal to 3 times x squared minus 6x plus 6. Now this function exists everywhere, so we only need to check to see when it's 0. If 0 is equal to 3x squared minus 6x plus 6, then 0 is equal to x squared minus 2x plus 2 by dividing everything by 3. So using the quadratic formula, we should have x equals minus 2, which is 2, plus or minus the square root of 4, which is minus 2 squared, minus 4 times 1 times 2, all divided by 2. And this is equal to 2 plus or minus the square root of minus 4 over 2. Since these two solutions for x are both complex numbers, there are actually no real solutions to the equation f prime of x equals 0. So that means there's no critical points. No critical points. In particular, none of them are minima or maxima. Problem 3. Find the global minimum and maximum of f of x equals x over 1 plus x squared on the interval 0, 2. First, let's take the derivative of f. F prime of x is equal to the derivative of x, which is 1 times 1 plus x squared, minus x times the derivative of 1 plus x squared, which is 2x, all over 1 plus x squared squared. Since x squared is always positive, the denominator of this will always be larger than 0, which means that this is defined everywhere. It remains to check where f prime is equal to 0. F prime of x is equal to 0 implies the numerator of this fraction is equal to 0. So 1 plus x squared minus 2x squared equals 0, or 1 minus x squared equals 0. So x squared is equal to 1, and x is equal to plus or minus 1. Now only plus 1 is actually in the interval we're considering, from 0 to 2. So let's check f at that point. F of 1 is equal to 1 over 1 plus 1 squared, which is equal to 1 over 2, which is a half. Now it remains to check the boundary conditions. So at 0, on the left side of the interval, f is equal to 0 over 1 plus 0 squared, which is equal to 0 over 1, which is just 0. And then f of 2 on the right-hand side is equal to 2 divided by 1 plus 2 squared, which equals 2/5. Now we know that the global minimum and maximum have to be among these 3 points, which means that 1/2, which is the largest of them, is the maximum, and 0, which is the smallest of these, is the minimum.